Okay, in this video, we're comparing and contrasting the attributes of a shape and its dilation on a coordinate plane. Alright, so I have two similar shapes here. If you notice, I have ABC, triangle ABC, and then I have triangle A prime, B prime, C prime. Remember, whenever you have a prime, and I'll show you what a prime is, it's that little mark right there, that is telling me that is the newer, that the original shape has changed, and that's what the newer shape is. So when you have just a regular A, that is the original. When you have a prime, it's the new shape. Alright? And so if you notice, our shape has gotten bigger. Alright? And these are called dilations. Dilation, and I'll write it out here so you can see it. Dilation, it's kind of like your eyes. When your eyes get dilated, the pupil gets bigger. But in this case, you can have them get smaller or larger in geometric shapes. Now, dilation is dealing with multiplication, and we're talking about scale factor. All right, so scale factor. All right, and scale means, of course, factor that we're going to multiply at the same rate. Okay, or each thing is going to be. So otherwise, it's going to get like the scale is going to get larger or smaller. All right, so the factor means multiply, of course. So we usually write initials SF for scale factor. All right, if the scale factor, so if our scale factor is greater than 1, then it gets bigger. Okay, so if we multiply our scale factor, so if scale factor is greater than 1, the shape gets bigger. Just like you see here. If you see A, B, triangle ABC, and then you see A prime, B prime, it got bigger. And we're going to look at the scale factor here to figure out. If the scale factor is between 0 and 1, alright, that means it's like a fraction or a decimal, then it gets smaller. The shape gets smaller. So let me give you an example. Let's say you have $10. If you take half, so half is less than 1, and you multiply it to $10, what's half of $10? 5. So you actually have a smaller number. You have a smaller amount of money. All right. Now, if you take $10 and you multiply it by 3, which is greater than 1, 3 times 10 is $30. So you've gotten bigger with money. Okay. See, so the same principle works with these shapes. Now, I have put it on a grid here so we can kind of look at how would we do this on a grid. All right, and it's really quite easy. You really don't have to do much here at all. Okay, scale factor is the new over the old. Remember, the new is the prime one. Okay, I'll put the prime there so you don't forget. We can pick any one of these points, and I'm going to say 6. We're going to take the x value of 6. So the new 6, you see it right there? This is the one I'm using right there. Alright, so we're going to say 6 over, and we got to take its corresponding point, which is 2. So if you don't know what I'm talking about, I'm talking about this guy right here. So I'm taking these two guys right here and putting new over old. Alright? And so that one will be a 2. I'll change that color. 2. And then so 6 divided by 2 is 3. So my scale factor is 3. And we could test that. So if I take 3 and I multiply it to that 3, do I get 9? Yes. Do I take 3 and multiply it to these guys, do I get 9 over 9 and 9? Yes. Do I take 3 and multiply it to these guys, do I get 3, 6, and 3? Yes, I do. So we could write this, and you may have seen this at some time. We could write this for this one like this. These are the notations for it. And so we're saying that we take our original and just multiply 3 to the x and 3 to the y. So my scale factor here is 3. It's gotten larger. Okay, here's another one that we're going to try. This one is trying to find the scale factor. And so notice I got two shapes here. I got to figure out which one's my original, which one's my new shape. And you should be able to tell by the prime. Okay, so scale factor is new over old. Alright, and like I said, the prime is the new, so this is the new, and the one that's not. So you can see that the shape's gotten smaller. If the A, B, C, D is the original and it's big, and then we go to A prime, B prime, C prime, D prime, and it's very small, we know that our scale factor has to be less than 1. Remember, scale factor has to be less than 1 for it to be smaller. If it's greater than 1, then it's going to get larger. So we know it is. Now, how much larger it gets? Well, we have to count here. Now, because I have my lines set up this way, I'm going to count 1, 2, 3, 4, 5, 6. So the bottom is 6. Now, I'm counting the space between these 1, 2, 3, 4, 5, 6. Now I'm going to count this space 1, 2, 3, 4, 5, 6. I think I messed up. 1, 2, 3, 4, 5, 6. So that's 6. Okay. Let's check my other. 1, 2, 3, 1, 2, 3. So this is 3, 1, 2, 3, 1, 2, 3. So this is a perfect square. So you can see that it goes from 6. I'm sorry. The new is 3 and the old was 6. Okay. See the 3 and the 6. So if I reduce that, I get 1/2. So my shape, like the scale factor, is 1/2. That means, just like I talked about earlier, money. If I had $6 and I took half of it away, or multiplied it by half, I'd get $3, which is the same situation here. I put scale factor is 3. Scale factor is 1/2, which is less than 1, which makes the shape smaller.